right, this lesson video is going over 9-4, solving quadratic equations by completing the square. Completing the square is actually a really important algebra skill. You do need to know how to do this. You will see it on your EOC. It's got steps to it. It's something new, so you're going to want to write the steps down for sure. But it's, I mean, if you understand quadratics and factoring okay, you should do just fine. Okay, so before we get into the actual completing the square, I want to review really quickly what we've already talked about when we factor polynomials, right? So a polynomial has multiple terms. If it's a trinomial, it's got 1, 2, 3 terms. If it's a binomial, it's got 2 terms, right? And there's other names for other polynomials. So when we have a trinomial, we can actually factor it, which means instead of having 2 binomials and multiplying them out to get this guy, I can go backwards and I can kind of divide everything back out into 2 binomials, right? What I had before, I multiplied them together to get this. So when I factor, I want to come up with all of the factors of the last term that add up to this middle term. So all of the factors of 18 that add up to 9 are 6 and 3. So I'm going to put a 3 here and a 6 here. And since the first term is x squared, x times x is x squared. And then all of our signs are pluses. So all of my signs in my binomials are going to be pluses. So I factor it to this point, and then I can continue on. If I just had to factor, I'd stop there. If I want to solve, I set each set of parentheses equal to 0. So I'd have x plus 6 equals 0, and x plus 3 equals 0, and then solve for x, right? So I'd get 2 different answers. Then we went over a few shortcuts, right? So if I have the answer, instead of this trinomial up here that looks like this, if I had a special case that looked like this. So for example, I'll write it over here in red. If I had, I don't know, 4x squared minus 36, right? It's a perfect square term minus another perfect square term. If I had something like that, I know sorry, I'm messing up my papers. I know the shortcut to factoring it looks just like this. So I take the square root of each term. The square root of the first term goes first here. The square root of the second term goes second. And then I plop in a plus sign and a minus sign, right? So that's my little shortcut I learned. So for this example, this would factor out to, I'd have 2 binomials, one with a plus, one with a minus. Doesn't matter which is which. The square root of 4x squared is 2x. And the square root of 36 is 6. So then that's it factored, right? And if it was equal to 0, I'd set each of these parentheses equal to 0 to fully solve it. Then I had another 2 set of shortcuts, right? If I have a perfect square at the end, and then in the middle is 2 times the square root of the first term, square root of the last term, right? That's a perfect square trinomial. So I know my shortcut is I just take the square root of the first term, the square root of the last term, and I know I can plop it into this guy, right? These are my factored terms. If it looks exactly the same but it has a minus in front, I'm going to do the exact same thing when I factor, but instead of plus signs, I'm going to have minus signs. All right, so those are my shortcuts. All right, so now what if I have a trinomial that's not a perfect square? It's not one of these shortcuts. How could I make it a perfect square trinomial? That's where it's going to come in, where we're going to use completing the square. We're going to have to complete the square to figure out what this last term needs to be to make this a perfect square trinomial. So typically all you're going to look at is just those 2 terms. That's all we'll have. Okay, so let's go right into this lesson. Up at the top, it says equations containing a perfect square on either side can be solved quickly by taking the square root of each side. Remember, if we had like x plus 2 squared equals, we'll use 36 again, and I wanted to solve for x, I would just take the square root, x plus 2 equals 6, and then it's no longer quadratic, right? That's easy enough. That's what this first sentence is saying. A quadratic equation that does not contain a perfect square on either side of the equation can be transformed into one by completing the square. Okay, so steps to completing the square. This is the important part. I know it's been a lot of talking. This is what we're going to be doing. Step 1, step 2, step 3. All right, So basically when you think of a trinomial that you're gonna factor, you think of it this way, right? A is the number in front of x squared, B is the number in front of x, and C is the plain number hanging off the end that doesn't have a variable with it. Well, right now for this first video lesson, we're gonna ignore C. That's what we're gonna try and find on our own, so we're gonna pretend like there's not already a C there. We're just gonna look at basically binomials that look like this. And then the number in front of x squared, in this case, A, is always gonna be 1. If it's not a 1, we have to make it a 1, and I'll show you how to do that. So we're gonna focus on things that look like x squared plus a number times x. Okay, so for that, step 1, find half of b, which is the number in front of x. Step 2, square that number. Step 3, add the result to the end of your equation. That's it, right? So when I have this guy here, the one I wrote on the back, over here, completing the square, I'm gonna follow my 3 steps, right? I've got this guy right here. I'm trying to solve for C, so I'm just going to focus on this part right here. The number, in front of x squared is just, there's no number, it's a 1, perfect. So I'm gonna look at the number in front of x, my b value, divide it by 2, and then square it, right? So I'm gonna have x squared plus 2x plus, and then I'm gonna take 2, divide it by 2, and then square that, right? And that's gonna be my C value, right? So then when I simplify that, x squared plus 2x plus 2 divided by 2 is just 1, and 1 squared is 1. That's it. So what does C have to be for this to be a perfect square trinomial? C has to equal 1. That would be the solution there if we're solving for C. We're trying to figure out what C is, right? If I wanted to check that in a perfect square trinomial, I'm gonna have both of my two sets of parentheses that are exactly the same. So instead of writing both out, I'm just gonna put squared behind the first one. And everything's a plus sign, so I'm gonna have a plus sign here. So it should be the square root of the first term is this first term. The square root of the second term is this guy. And if I multiply this times 2, I should get here. X times 1 is x, times 2 is 2x. So that fits. So this is the factored version of this, right? But I had to know what this number was before I could factor it. So that's completing the square. Step 1, take the number in front of x, divide it by 2. Step 2 is to square it. And step 3 is to add it on to the end of x squared plus bx. All right, I hope that's making sense because that's literally the only steps to it. So let's do, I highlighted 4 problems here to try. And I'll zoom in a little bit. Okay, so it says find the value of C that makes each trinomial a perfect square. So we're solving for C right now. We just got to figure out what it is. Okay, so I'm going to ignore C and just look at the first 2 terms, x squared plus 14x. 14 is my B value. So I have to divide 14 by 2 and then square it and then add it on to the end. That's going to be my C value, right? So C equals 14 divided by 2 squared, right? So 14 divided by 2 is 7, and 7 squared is 49. So the value of C here, this equation to be a perfect square trinomial, it would have to be x squared plus 14x plus 49. And the, oops, you can't see. And the factors of 49 that add up to 14 are 7 and 7. So that makes sense. This is now a perfect square trinomial. Okay, let's do the next one. Number 3 has a minus sign in it. Okay, exact same thing. C, to find C, I have to look at my middle term, -4, divide it by 2, and then square it. And whatever I get, that's what I'm adding on to the end here for C. Okay, so -4 divided by 2 is -2. And -2 squared, I'll put it in parentheses, -2 squared is +4. So for this to be a perfect square trinomial, it would have to be x squared minus 4x plus 4. Right, so C, oops, I don't know if you can see that, sorry. C has to be 4. Okay, next one. Let's do number 8. They're all the same, so I don't want to waste time doing too many. Okay, same thing. We got to figure out what C is for this to be a perfect square trinomial. So to find C, I have to divide this by 2, the middle term, square it, and that's my C value. So C equals negative 15 divided by 2 squared. Negative 15 divided by 2 is negative 7.5. Negative 7.5 squared is 56.25, and it's going to be positive since we squared it. So positive 56.25 or 56 1/4. Oops. I zoomed in too far and you can't see me. Okay, so this C value right here, for this to be a perfect square trinomial, would have to be 56 1/4 or 56.25. So that would have to be x squared minus 15x plus 56 1/4. Okay, let's do one more. Number 9. Same thing, to find C, I gotta look at B, the number in front of x, divide it by 2 and square it. 28 divided by 2 is 14, and 14 squared is 196. So this C would have to be 196. This would have to be x squared plus 28x plus 196 for this to be a perfect square trinomial. They don't all have to be perfect square trinomials, but if it asks you to figure out what would make it a perfect square trinomial, that's how we figure it out. Complete the square. Look at the middle number, divide it by 2, then square it, and tack it onto the end. Okay, stay tuned for lesson video 2. We're going to do more with completing the square, and let me know if you have any questions.